Alright, this is the finding domain and range from a graph video. The domain of a relation is all the input values or the x values. So we've done a list of points, like so, and we would find the domain, and we said the domain was the x values, so that would be 1, 3, and 5. Okay, we've done a table. Okay, it looks like this. Okay, and we said that the domain are all the x values. Okay, and of course we've done the mapping, which looks a little bit like this. And again, the domain is all the x values, 1 and 2. Okay, so when you go to a graph and you're looking at a picture, the domain is going to be all the x values. Well, the x values is left and right. Okay, so from the very left of the graph to the very right of the graph, how long the graph is. Okay, so from a graph like this, the domain would start here and end here, and the domain would be how far left this x value is and how far right this x value is. It'll tell you the length of the graph from left to right. The range of a relation is all the output values or the y values. So again, when we had ordered pairs in a list like this, the range were the y values, so like 2, 4, and 6. Okay, in a table, the range again was all the y values. So in this table, the range would have been 4, 5, and 6. Okay, and then in a mapping, looks like something like this. The range would have been the y values, 4, 5, and 6. So on a graph, the range is going to be all of your y values, how tall the graph is up and down. Okay, so using a similar example to the domain, if I make this squiggle here, the range is going to be the tallest point, how tall the graph is, to the lowest point. Okay, and that range from low to high will tell you how tall the graph is, and that's your range. That's the lowest y value you can pick and the highest y value you can pick. Alright, so what is the domain of the graph and what is the range of the graph? Okay, so the domain, I guess, again, is going to be from left to right. Okay, so how long is this graph from left to right? From left to right. And that'll tell you the length of the graph. Okay, so the very left point on this graph is right here, and that's at -5. The very most right point on the graph is over here, and that's at +5. Okay? Just like with regular inequalities, a closed circle gave us the less than or equal to symbol. The open circle here gave us the regular less than symbol. So this tells us all of our domain values, all of our x values are between -5 and 5. Alright, what is the range of the graph? So this is how tall the graph is. Up and down, how tall is the graph? Okay, so the very lowest point on the graph, this is going to give us our range. Our very lowest point is down here, and it happens to be at -5. Our very tallest point on the graph is right here, and it's at 5. So again, the lowest point was an open circle, so we used a less than symbol. The highest point on the graph was a dot or closed circle, so we used the less than or equal to symbol. So this tells us the lowest point's -5, the highest point's 5, and all the numbers in between is the range. Alright, what is the domain of this graph and the range? The domain is the x value left and right. Okay, so if you look at this graph, on the previous graph we had dots ending the graph. On this graph we have arrows. So that means that this graph will continue to go left forever and continue to go right forever. okay, because of those arrows. So in math, left forever would be negative infinity, and right forever would be positive infinity, okay? The range, okay? The range starts, the lowest point is right here at -5, it looks like. And since it's on the graph, it is a point, it's not an open circle, we will use the less than or equal to symbol. Okay? But just like the domain, this graph is going up forever. That's what these arrows mean. So it's going to get taller and taller and taller forever. It's going to get fatter left and right forever. But it's also going to get taller. So it's going to go up forever. So that would be infinity. Alright, last example. Our domain is our left and right values. So the left value here, the graph starts here at 0. Okay, we're using a less than or equal to symbol because there's not an open circle there. Okay, it's on the graph. There's a dot that we could put there. Okay, and then the graph, because of these arrows, is going to continue to go right forever and ever and ever. Okay, so because it's going to go right forever and ever and ever, we would put infinity. Alright. The range. The range is going to be how tall the graph is, up and down. Okay, now this graph looks like it would start here and go to here. Okay, but again, because of these arrows, it's actually going to get taller. It's going to continue to go right, and it's going to go right really quickly, but it is actually going to open up and get taller. Okay, eventually it'll be really, really, really tall. So it is going to continue to go down forever and up forever. So it is going to be negative infinity to infinity. Okay.